Alrighty. Hello, my name is Noodlecat, and today I'm going to show you how to do this. So, this is a tutorial that's going to show this very specific thing that I do for my Unreal Engine VTuber setup. Basically, we're going to go through like how to use multiple meshes in one Niagara system, and then how to export Niagara data into blueprints. So I'm going to skip the Twyworks setup portion of this whole process, mostly because Riku TV has a very good tutorial that I followed to get this set up, so I will link that somewhere else if you want an in-depth version of how to get all this working and how everything works. So first thing we're going to want to do is create a new emitter. I specifically made one from selected emitters, and I just threw in the fountain. Finish. We'll name this tutorial. Alright, we'll open that up. Alright, so this is your basic fountain emitter. First thing we're going to do is hop into velocity. We're actually going to reset this random range. And we're going to change this from in cone to linear. And just set this to 0. We're just not going to add any velocity to this. Next thing I have in here is an initial mesh orientation, which is perfectly fine with these settings. Next thing you have to do in the particle update is you'll add a update mesh orientation. And then all of these settings are fine as well. And then we will add collision. There we go, so that I can actually collide with my model. Again, these settings are fine. And then the last thing we need to add under the render is we'll add, oh, it's right there, the mesh renderer. We can turn off the sprite renderer for this. And that's your initial setup. And something interesting about the mesh renderer, if we click on that, we can actually input more than one mesh. Right now you kind of have this little gizmo here, but you can drag in, you can make as many as you want. You can see the index ticking up. So what you can do then is you can actually set which piece of geometry you want to spawn out of this system. And to do that, under particle update, you're going to scroll down and click on set new or existing parameter directly. You're going to press the little plus icon, and we're going to search mesh and click on mesh index over here. So then that will basically set the mesh index in your mesh renderer. So then what you can do is you can make a user parameter, which will be int, I believe. Yeah, int 32. I'm just going to name this mesh index. And you can just assign that to this mesh index parameter that we have in here. So now essentially this mesh index parameter can now be seen and controlled by the user or by whatever blueprint you throw this into. So in my setup, I have a couple other user parameters that which can assign values to. So I'm just going to walk through how I do those. The first one is to assign the spawn rate, which you can see is already up here, but we want that to be controlled by the user. So we will create a new float user parameter. I'll call this spawn rate. So then what you can do is you can go up to the spawn rate and click and drag this parameter over to the spawn rate. So now this number will assign what the spawn rate is. And we can do the same thing to let the user control gravity, which is a vector actually. So we'll create a vector parameter, call it gravity, and open your gravity force, click and drag, same shebang. And the last thing that I have users control is the launch speed, which honestly is just kind of related to the gravity here, but we're going to make our own new vector parameter for that. speed. We're actually going to have that controlled by our launch speed here. And that's it for the user parameters. Next thing we want to do is make a blueprint to actually control all of these user parameters. I'm just going to show you my blueprint. Hopefully that'll be helpful. Here we go. This is the blueprint. We'll get to that later. First thing that we do is we get all the info from a different blueprint that I have, which basically brings in all the Twitch information that I showed earlier, and then we bind that to an event dispatcher that I already have made over there, so that when somebody calls that redeem, it basically calls this action. Then this down here grabs the message for the redeem, splits it into all the pieces that we need, which is what they actually want to throw, the spawn rate of what they want to throw, like how many will it spawn, and the force, the launch speed essentially, which actually takes both the launch speed and the gravity parameters into account. Let's focus on the first bit of this here. Basically what we do is we switch on string based on whatever this this first element of the string is, and we see if it has any of these strings within it, and depending on that we set the mesh index, which is just a variable that I have over here, but then pipes into this function. For the spawn rate, essentially we have these three nodes, the map ranged clamp nodes, which basically I arbitrarily set the maximum and minimum values that someone can put in at 1 through 10. These are entirely arbitrary, whatever you want to pick. So that's your in range, and then the out range is what it spits out. It'll basically take the difference between these two and then map it to the difference between these two. So it'll take 1 through 10, and like say you pick 5, which is right in the middle of those two, then it will basically take whatever is in the middle of these two values. And these are also arbitrary. This is just the spawn rates that I found to be most interesting for this project. And then you do something similar for the launch speed and gravity. Like, I think, yeah, this one's the gravity. This is either like really, really low gravity versus like what your normal gravity would be. And then basically you would force that into the vector that you want to be making. So the launch speed is in X only because things are being launched in the X direction, and Z is the up and down axis in Unreal Engine, so you're basically just mapping this value into Z so that you have up and down gravity. And all of these get put into this function that I have graciously named throw shit. And essentially this is what grabs everything from the Niagara system and sets all these variables, right? I have my spawn rate, I have my launch speed, I have my gravity, and I have my mesh index. These basically take all the inputs that we just put in there and sets each of these to be the appropriate value, right? Your mesh index is right here, gravity, force, launch speed, spawn rate, and after it sets all of that, it activates the Niagara system. One important thing that you should note when you pull in the Niagara system into your blueprint, at least for this example, is you want to turn, you can't see that, let's put it up here. You want to turn auto activate off. It's just not something that is useful for this example. Like then, like the moment you press play, it'll activate that system, which is not what we want. So yeah, that's most of what goes on in this blueprint. Next is we're gonna get to this stuff. So this bit of the blueprint here is very specific to the fact that I wanted to be able to play a piece of audio on collision. which actually if we hop over to the Niagara system again, there is actually a play audio option here that you can actually go in and set a single audio file to play on collision. This makes it really easy if you only need one piece of audio to play, but things get a little bit more complicated for this example because we have multiple different meshes that we could be throwing and different sounds that we want associated with those. So in order to do that, we sort of have to do things manually. So let's get rid of this play audio. So in order to do that, we basically have to manually make an event for this blueprint that says, hey, something is, or like this particle is colliding with something. So in order to do that, we hop in here to particle update. We add a little option called export particle data to blueprint. Very, very useful. Essentially, you can also bring different attributes. Like you can send the position, you can send velocity, you can send a lot of this other information. What we want to send is basically, has this particle collided with anything? So in order to do that, what we have to do is tick on condition to export data. And if we go down into this drop down, we can actually set something called collision valid. It's under output collision. It just says collision valid. Basically, it will only export this particle data if collision is valid. So then what you have to add is something called a generate collision event, which will generate the event. And what this will do is give you an error that says this requires persistent IDs. This is an easy fix. All you have to do is hop into the properties of your emitter and tick on requires persistent IDs. And then that error should go away. And then the last thing that you want to do is hop into here and you'll want to set this callback handler parameter, which is, this basically tells the system what blueprint you want to send this to. So then what you have to do for that is you have to make a new user parameter, which this one will be an object, just a plain old object. We're going to call this BP callback. And then once you have this made, you can basically click on this drop down and select your callback parameter. There you go. And then from there, we would hop into our blueprint, and then we would set this. Essentially what this does is, first thing you do at event begin play, you will set a Niagara variable by string. Because it's a user parameter, you have to throw user dot in front of the name of your parameter, which again is named blueprint callback. You can name it whatever you want, but that's our callback parameter. Throw in the system, and then you will want to have this reference itself, basically saying, I want this information to be sent to this blueprint. So then once you have that, you can get this event set up, event receive particle data. In order to find that, you'll hop up into class settings. You will go over to interfaces, and I'm covering it here a little bit, but you'll go down to add. I already have it here, but what you'll search is Niagara particle callback handler. So you'll make that. And what you do is you go over here to interfaces. It will show up here, receive particle data. You will right click, and because I already have this in here, actually let me delete that. You can right click, implement event, and then it'll throw that into your blueprint. And you can tie that to whatever you want to have happen. In this case, on collision, which what I want to happen is for it to play a noise depending on what mesh I have selected. So we already set the mesh index stuff over here, and basically we'll also feed that information of what is actually being thrown into this audio cue, which I can open real quick. It's pretty simple, but all that is you have these different files that you can throw into a switch on parameter node, which the parameter I have is called audio by mesh. So you have the parameter, change that integer based on this input, and then after that it just plays the noise. And that's how you play that noise on every collision depending on your mesh index. So there you go. That's how I have a Twitch redeem that allows users to throw different meshes at my face through Niagara. Let me know if this was helpful for you, and let me know if you want me to make anything else like this in the future. Bye!